programming course. So the whole idea is that during the regular classes, we might not have enough time to discuss all the cool things that programming in general and C++ in particular has to offer. So that's why we had an idea to organize this cycle of the lectures. So what's today's topic? References and pointers, right? So first of all, as you all know, I am an English teacher actually. So we're going to start with spelling. Okay. So first of all, I want to start with what you already know. What are references? What are pointers? How references look like? How pointers look like? So what's references? What pointers?
References and percent, pointers.
Okay. So we have this special character that you probably have seen. It's called ampersand. That's references. And pointers are represented as an asterisk. Great. So today we are going to discuss A, what are they, B, what's the difference between them, and C, why we need them at all. Right? So why to use them instead of using just regular good old variables. So let's start. Let me erase all of this. So the idea, when I say int a equals to 5, what's going on under the hood? A variable is created. The variable is of type integer.
So
Its name is a, and its value is 5. What's going on even more under the hood?
The memory is allocated.
So we have some memory storage for our program, right? Every time our operating system runs a program, it allocates some chunk of memory for that purpose. Right? So what does that mean? So for instance, your PC has 16 gigabytes of operating memory. Your PC has to run a lot of different programs. So that's why operating systems tries to manage the memory between the programs. And so you're given some, your program is given some, for instance, I don't know, 1 megabyte, 2 megabytes, 20 megabytes. So some certain amount of memory, and then the program itself manages it. And so when we create a variable, how much memory is allocated for an integer?
4 bytes, typically.
So an integer is, I mean, again, it can theoretically depend, but yes, as Luna correctly said, typically it's 4 bytes. So of all our memory, we allocate 4 bytes. So let's imagine. So we have a memory like this, right, in form of a glass, let's say. So and let's say that our memory starts at 1000, right? Everything below 1000 belongs to other programs, and ends at 5000. So the more information about how memory works, by the way, will be on the next lecture in the series that Tora will do, Professor Ignatiev, next week. But for now, what we need to know that a variable is created, right? So 4 bytes of memory are created, starting from address. Give me any number from 1000 to 5000.
2000.
Okay, sure. 2000 and then ending at 2004.
4.
Let me write it. An engine at 2000. Come on. And 4. Okay. So that's what regular integer variable is. So now let's discuss about this line of code. Right? So what's this? It's a pointer. What's a pointer? So it points to something according to the name. What it points to?
Memory.
An integer that holds a memory location.
Right, so it's an integer. It's a pointer to an integer, but it's itself is an integer, right? So if you have a pointer to, for instance, in string, like this, it also points to some place in memory, so it's also an integer. So for instance, if you have, do you guys have 32-bit operating systems or 64-bit operating systems?
64.
Do you know at least that there is a difference, right? So there exists 32-bit and 64-bit. What's the difference? Why they're called 32-bit operating systems and 64-bit operating systems?
Instruction size.
Size of the long.
So there are many differences, but one of them is the size of pointers. So in 64 operating systems it's 4 bytes, in 32 operating systems it's 4 bytes. It's related to the fact that 64-bit number can hold a wider range of, well, numbers. Right? So 62-bit pointer can only hold a number from 0 to 2 billion, right? Why? Why 32-bit integer can only hold up to 2 billion?
2 to the power of 32.
Yes, 2 to the power of 32. And so 2 billion is 2 billion bytes is approximately how many gigabytes? 4. So if you ever having more than 4 gigabytes of operating memory, and I'm pretty sure that if not all, that all computers in this room has more than 4 gigabytes of operating memory, you need to have 64-bit operating system. Because otherwise, remember, pointer just points to the location in memory. So it does that by just storing the address. So for instance, we know that A is equal to 5. So the address of A at the same time is what? 2000. Right. So the value is 5. The address of the value is 2000. So if we want to store where where A is located, we need to create a pointer to an integer and say, come on, oh yeah, I cannot do this on this whiteboard, and say that we want to store its address. Let's do, for instance, right? So we create a pointer. So it means a thing that will store an address of something. And we are writing that that pointer is equal to this. So what this means?
The memory location of that variable.
So I see the people are confused. So let's go from the beginning. Not from the beginning, do a step back. So this means that we are storing a pointer, and pointer stores a place to a memory. Now we need to say to what memory it stores. It stores location to. And the idea is that that variable A, let me time to recollect. Why am I hearing stage scare after I already taught 25 billion classes? Who can tell me? I'm literally having a stage scare now. Give me a second to recollect.
Don't worry.
No, seriously. It's generally weird because I taught classes to wider audiences. So this operator, it's an operator. It's just like you can write, for instance, minus A, you can write A plus B, you can write, for instance, things like, I don't know, A multiplied by B. So all these special symbols that we use are operators. So for instance, what kind of operator this is? Addition. This is multiplication. This is? No, it's not subtraction. Subtraction it would be if you had 2 numbers. We have only one. Negation. Right? And so there are many operators in C++. We will discuss some of them on the lecture on Monday, by the way. What other operators you know? So yes, you know and. you know, or you know division, you know greater, less. Do you know this kind of operator?
Yes.
Do you know this kind of operator?
Point.
Ternary.
Dot.
Remember the way to do ifs in shorter way?
Yeah.
This is called ternary operator and so on. So this, in this case, is also an operator. So it means that it does something to its value. The values that we have here is 5. So the question is what exactly it does to that 5. So the name of the operator is address of operator. So can you guess what address of operator? It's written like this. Address of. What address of operator does?
Gets the address of the variable.
It gets address of the variable. What's address of variable A?
2000.
So that means that it will find number 2000 and will put it to the pointer. Right? So the point, it means that if we, so now this variable editor, it stores the address to variable A. Now, for instance, it can be done with the strings as well, or with objects. Do you remember having the following code in your practice 2 actually? It was something like that you have array of turtles, right? And it has 2 turtles, right? Let's for simplicity say that turtle 1 is on coordinates 1, 0, and turtle 2 is on coordinates, I don't know, 0, 5, whatever. So you have an array of turtles, right? So we say it's an array of turtles. And then you have a following line of code. Turtle pointer, turtle equal to address of turtles 0. Right? Turtle 0. Remember this line of code? You had it in your program. Now it's time to fully understand what's going on. So, what's happening on this line? Generally, what we are creating?
We initialize the
We create a variable. What type of the variable? No, turtle pointer, right? So this is our type. Turtle pointer type. What its name? Turtle. That's a little bit confusing in the code. So let's, for simplicity, to differentiate the names, we'll name it, instead of turtle, we'll name it my turtle, right? So, so my turtle is a name. Turtle is the name. And the last part, after the equality sign, what it contains?
The address.
So usually, when we create a variable, when we in a equals 5, int is type, a is name, 5 is value. So the value here is address of turtle 0. Address of turtle 0. So we take the first element of our array and we find its address and we store it in the pointer. Why? Why not to just do, remove pointer here, remove reference here, and just have turtle my turtle equals turtle 0?
It just copies the object then.
Yes, about this in a second. I want to hear other people's opinion.
So we can overwrite, maybe.
We can overwrite it 0, right? So if you say int a equals to 5, you can later say, right, that a equals to 6. Nothing prevents you. Why to do pointer though?
Because they're flexible and it's convenient for.
In what sense?
Maybe it's addressing exactly to that number.
can change that.
Yes, again, it's addressing to the memory, sure, but what's upsides it has? What advantages it has? Instead of just doing regular way.
We don't get copy.
Exactly. So what Luna said, but now let's yes, and Natai just said. So when we do like this, it actually copies the context of turtle 0 to this variable my turtle. So how many different information turtle has? Not that much, right? Coordinates, direction, and pen up and down. Five variables. But now imagine that instead of turtle, it was, I don't know, field, for instance. Field has how much information? How many different variables field has?
Multi-dimensional array.
It has two-dimensional array and size and stuff and so on. So that means that every time we need to copy a field, we copy that two-dimensional array. Now imagine if that two-dimensional array was not 20 by 30 elements, but it was 2 million by 3 million elements. How much time it will take to copy that? Quite significant amount of time. So the idea is that in C++, when possible, we want to avoid copying objects. And if, or like big data types, if we had a very big array, again of 1 million elements, we also don't want to copy it. So instead of copying it, we want to do something else. So if I will just write turtle, my turtle equals turtle 0, we will copy turtle 0 and all that is inside in here. If turtle 0 is a big object, so for instance, I don't know, imagine that we are developing a university, some kind of program, right? That e-course, for instance. Imagine we are developing e-course, and there is class, well, course, and that class contains all the files that are on e-course. So if I uploaded 25 videos on e-course, 7 books, and so on, they're all stored in that object. And imagine if I needed to copy that object every time. How much time it would take? Copying 7 books and 25 videos. How much time it takes you to copy a video?
A lot.
But several seconds at least. So we want to avoid this. And pointers allow to avoid this. Because instead of copying the entire object, what do we copy?
The address.
So imagine again, we have my turtle here at the address 2000. Right? So we have address 2000. And here we have our turtle 0. So by result of this line, turtle pointer my turtle address of turtle 0, what will we copy?
2000.
We will copy only address 2000. We will not copy everything that is the entire turtle. So basically, instead of asking, instead of coming to registrar and being like, hey, can you give me my transcript? And they are printing it for you. You say, hey, can you give me a link to my transcript so I can look at it? So what will be faster? Asking them to print it or to send you the link on average? So imagine if they need to go to the third or to the second floor where we have printers and print it there and so on and so on. So asking registrar for paper copy of your transcript is equivalent of copying a variable. And asking it to give you a link, some pointer to your transcript, is the equivalent of using pointers. So the idea, so that's the thing that we have in C++ since C. So in C, they obviously also wanted to do that shorter, and they were using pointers. So one another place where you might see pointers in real life, it's in something like this. Can I erase it? Oh, it's in something like this. So we have our field, right? And in our field, we have our two-dimensional array of data, right? Familiar code? Cool. In many C programs, and even in some C++ programs, you will often see this, instead of being written like this, it will be written, come on, I want orange. Here we go. It will be written like this. Oof. What's going on here?
Great, pointing to references.
Wait, look. What's going on here? So here we have our two-dimensional array. What do we have here?
Maybe it instantly points to the variable that has the same name.
Variable that has the same name, yes, but why two pointers?
In order to automatically point it.
So what's array under the hood? Right? So what array again? Okay, so we have this memory, right? In memory we have array, for instance, of 5 integers. It means so it's gonna be integer number 1, then immediately after it, integer number 2, integer number 3, 4, 5, and 6. So if we have array of 5 integers, how many bytes that array is gonna take? 20. 4 per integer multiplied by 5 integers equal to 20 bytes. So why 20? Because all integers are located one after another. The first integer starts, the second integer ends. So the idea is that actually when you are doing stuff like this, what you're doing?
You're getting the pointer and you're adding a value.
Yes, you find the third element of the array. So this is our data 0, this is our data 1, data 2, 0, 1, 2, 3, and 4. So we take data 3, right? So we take this element of our array. How do we find where that element is located?
We get the address of the first variable. And
Wait, Luna. I know you know, or at least have good idea. How do we find where data 3 is located? So imagine we want to print it or something. How do we find where it's located? So with regular variable, if I, for instance, want to find where variable A is, it's easy. You know where variable A is located, you go there, you take it out. How to do it with an element of the array?
Maybe we count by 4 bits, 3 times. Or
Mhm.
something like this.
So we take a start of the array, and we know how many steps we need to do. 3 steps. So we at the start of the array, we add 4 bytes once, 4 bytes twice, 4 bytes 3 times, and we arrived at the element we want. Right? So when we are actually storing an array in our variable, what we can do, we can store the address of the beginning of the array, right? By the way, is it confusing that I go from bottom to top?
No.
I hope it's not, because that's how it's done actually in the actual implementation. In any case, you store the beginning of the array, and when you want to go to the third element, you just go up, right? So, and if array is just storing the beginning of, if storing an array is just storing the location of the first element, how can we store it? Do we need some fancy schmancy data structure for it? Do we need some fancy schmancy 25 billion bytes?
no.
What we can use instead, right? So we have a pointer to an integer, right? So for instance, this is address 1000. Like this. This is whatever 100,000, doesn't matter. So we know that in that array, in that address we have number 100,000. If you want to find the third element, we add 3 times 4, 12 bytes to that element 100,000, and so and we get to the element number 3. I see I've lost some people. At what point you have lost me? Come on. Okay, so is the idea why an array is just a pointer clear?
Yeah.
Why? Tell me in your own words.
Because array points to the first item,
Mm-hmm.
and it doesn't essentially need point every item because it can just step every single.
Right. So we don't actually need to store the entire array in our variable. We just need to store the beginning, and then we can count how much we need to add to that beginning to get to the element we want. So that means that every time we copy an array, we actually don't want to copy the array because that's unnecessary. We can just copy the address of the beginning of the array, and then add 4 bytes until we get to the element we want. So let's do a little exercise. Let me erase all this.
Excuse me, so why there are 2 pointers? Because
We'll get to 2 pointers in a second. Let's figure out 1 pointer. So we have this memory, right? And we have our data starting at address, I don't know, 2000 for instance, right? So we want to get to element 5. What address it will have? 2000 plus what?
Plus 20.
Plus 5 multiplied by
Size of
4.
4. Why 4?
each.
No, because we assume that data is integers, right? Okay, what if we want to get to address 10,000? No, let's not say 100, okay, not 10,000. What's the address of data 100?
2,400.
2000 plus 100 times 4. If our array is not integers, but instead, I don't know, a chars, what the size of one char?
100.
A size of one char?
1 byte.
I'm sure we discussed it in intro. A size of one char? 1 byte. So then if our array of data is actually chars instead of integers, what is going to be location of data 5? 2000 plus 5 times 1. And here it will be 2000 plus 1000 times 1. So, but then, look, this will get just the address, right? But instead of the address, what we want? Do we want the address of element data 100 or the element itself?
Element.
So, and this one important thing has. So look, when we have just a regular variable and we want to get its pointer, what operator we use again? What was its name? No. We have, so we have, for instance, an integer, and we want to get a pointer to that integer.
Address of.
We use address of operator. Okay? And now we have a pointer to the variable, right? So we have the address of that variable. And we want to get the variable itself. What operator we use?
A star.
Wait. What operator we use? That's very confusing, I know. I would personally ask Ricci and what was the second guy who invented C, why the hell they decided that's a good idea. So asterisk means that given an address, go and fetch what lies there. So for instance, imagine I told you that, I don't know, Atay, a book I want is located in locker number 343. Can you fetch it for me? And Atai goes and fetches the book for me. So the book is the variable. What's locker 343? It's address of that variable, and Atai is the reference operator. This operator is called the reference, spelled like this. The reference. So, and the opposite. If I go, Atai works at the library, and I go to the library and say, Atai, where is War and Peace is located? And Atai tells me it's located on shelf number 17. War and Peace is variable. Shelf 17 is address of that variable, and Atai in that sense is
Reference there. Oh, wait.
address of operator. Make sense? Right? So address of gives you an address from the variable, and the reference gives you the variable from the address. Right? So there's the opposite operators. Just like plus and minus, multiply and divide. I don't know, you haven't discussed derivatives yet, right? I don't know, logarithms and powers. So they are opposite operators. Address of and the reference. So when we want to find our data file, after we calculated its address, what we need to do? We need to dereference it to get the actual value of it. The same is here. After we get the address of, we calculated where element data 100 is located, we need to dereference it to get the element itself.
You would dereference it because data 5 by 5 index it's a pointer.
So the idea is data is a pointer.
Oh, okay.
Right, so it's this number 2000 because data is located at location 2000.
Yeah.
We add to it 5 or 20 depending on whether it's integers or characters, right? So whether one element is 4 bytes or 1 byte. And after that we find that, oh look, so we took number 2000, we added 20 to it. So our data 5 is located here. But we know that it's located here, we don't know what's located there yet. And to figure out what's located there yet, we do the reference operator. So basically, let me erase all of this. Every time you see something like this, int array, right, an array that consists of element 1, 2, 3, 4, 5. And we want to print, I don't know, third element of it. What we're gonna print? What we're gonna print? 4. So, what works under the hood? So data, remember, oh sorry, not data, it's called array already. I renamed it. So array is a pointer, right? So it's some address in memory. Let's imagine it's address 2000. Then to that address we add what? 3 times 4. 3 because of this 3, 4 because it's an integer. And then that is address of that element array 3. But we don't need its address. We actually need its value. So to get the value, after finding the address, we do reference. So these two lines of code are absolutely identical. So especially if instead of 2000 we write array. So these two lines of code are absolutely identical. So we go to the beginning of the array. From the beginning of the array we find the address of the element we need. And then from the address we take its value. So analog is, imagine I tell you that you first go to the library, and in the library on the third shelf you take a book, I don't know, third shelf, 10th book from the left, and you read it. So you first go to the library. You know the libraries. The libraries on the third floor, right? So you know where the library is. You have a pointer to the library, and after you led to the library, you follow additional structures. I don't know, third row, 10th book, and after you find the book, what you need to do? So you find it with your eyes. What you need to do? You need to take it. This is the reference operator. So that's why arrays are actually just, again it doesn't work that way, it's just pointers, right? So they point to the starting location in memory, and then from there you can figure it out. Now the question is, what if that's double pointers? What does it mean? What's double pointer? Opinions? What can be double pointer?
Just a
Mhm.
pointer to a point.
Pointer to a pointer. Great. What's your name? Burhan. Okay. Burhan is correct. It's a pointer to a pointer. So look, now we are going a little bit Inception. Did you watch Inception? Как по-русски? Начало. Yes. So what is it about? It's a dream inside a dream inside a dream. So look, we have our, we have, for instance, number 5. Oh, come on. We have number 5. That number 5 is located at the address 2000, right? So this is number 5. So the pointer to number 5 is going to be what? Okay, let me write it correctly to not be confused. So we have in A it equals 5. So the pointer to the pointer to A is located at number. So the pointer to A is 2000. And now, so 2000 is also a number, right? So this is also some kind of variable. It's also stored, it has to be stored somewhere. So what if we take a pointer to that value? Right? Again, a dream inside of dream. So pointer points to A, and now something else points to pointer. So that's what double pointers are. Address of pointer. So a dream inside a dream. Do you think triple pointers exist? Of course they do. There are even pointers of nth degree exist. So a pointer to a pointer to a pointer to a pointer to a pointer. I will not go into details, but that's exactly how 2D arrays, 3D arrays, and 5D arrays work. So when you increase the pointer to a pointer, you switch from one layer of 2D array to the second one. And when you, and that's how all this mathematics work. If people will want after that of the lecture, you can say and I will show you how it works with the idea of 2D arrays. But so for now, what I want you to understand. So first I want you to understand that pointers are just stores the address of real variables. Then address of operators get the address of real variable and stores it in a pointer and allows it to and converts it to a pointer to that variable. Then the reference operator takes a pointer. So if I do this, by the way, what will be stored in B?
The number and the variable inside, which.
So imagine I've written it somewhere under here. So int pointer equals address of A, int B equals the reference of pointer. So b will be equal to 5. Here you go. So I want you to understand this. So the reference and address of are opposite operators. And the third thing that I want to understand, that all arrays are just pointers in this case. At least regular good old arrays in C that you are using for all your work until now. What questions do you have?
Is there any limit for pointers?
What do you mean limit?
No, like
Limit in what sense?
limit for dimensions.
No, so if you want to represent multi-dimensional arrays, you just add more and more pointers. So if you have int pointer, 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 it's like a 5D array. And what value a pointer can take is related to, is equal to the size of your operating memory. So for instance, if you have 8 gigabytes of operating memory, and you'll try to make pointer equal to, 19 trillion, it will say out of memory. Because you're trying to point to the place in the memory that doesn't exist, because you have only 8 gigabytes of it.
We're talking about the pointers, for example, like turtle, right?
Mm-hmm.
So in turtle it has many variables inside,
Mm-hmm.
right? And so how does exactly like this pointer?
Great question. Let me erase all of this again. So, for instance, we create. So, what variables turtle has? We decided 5, right? X, Y, gx, dy, pen up, pen down. So, pen up, pen down is a boolean, so it's technically 1 byte. But for simplicity, let's say that it's an int and it's also 4 byte. So it means the turtle, how many bytes it takes? 20. 5 times 4. Each variable takes 4 bytes. So we create turtle number 1 on the address 2000. Right, so this is our turtle 1. So it means where turtle 1 will end? At address 2020. And then we have our turtle 2 in the same array, right? It will start at the address 2020 and finish at address 2040. Here you go. And when we want to decide which turtle we control, we just look up the pointer, so look up the address of the turtle that we want and talk to it through through that address, right? So that's why again all of that weird stuff. So turtle pointer my turtle equals to address of turtle one for instance, right? So it will find the address of turtle 1, which is 2000. I mean, there are discrepancies in discrepancy, but that's fine. It's 2000, and it will put it there, and then we can talk to that to this concrete turtle through that address. So there are 2 ways, by the way, to talk to an object through the pointer to that object. What are those 2 ways? What are the 2 ways to talk to the object through its pointer? What do I understand by talk? Let's start with this.
Call function.
Call function from it, yes. So how can we, for instance, call function turn right from a turtle, from an object of class turtle, using its pointer? 2 options. Yes, so first we can do arrow, right? So you'll say turtle, my turtle, I'm sorry. My turtle, arrow, turn right, for instance, right? That's the first option. What's the second option?
Dereference. Dereference.
Star and
Yes, so first we make the actual value from our pointer. right? So we get the actual object from our pointer.
Number
And then we put a dot to call it as usual. Hmm? Come again?
It's member access operator.
Memory access operator, yes, that's a smart name for this dot, dot thing. Oh, you want smart name for this operator, by the way? What's the smart name for this operator?
Stream instruction operator.
Two errors.
No, no, not stream instruction operator. What's the fancy name for this? You will never guess.
It was in the book, I forgot.
Busy.
It's bit shift to the right, and this is bit shift to the left. Why bit shift and so on and so on? Well, maybe you discuss that on like computer architecture or on data structures. Anyway, yeah. So all these operators have fancy names. We know this as dot operator, and this is cin operator, and this is cout operator. But of course, they have fancier names that their actual names. Anyway, so is it clear that these two things again are completely the same? So arrow is used to access something through a pointer, and the dot is used to access something from the variable itself. Okay, so we talked already for 45 minutes, and we haven't talked about something else. Right. So, questions about, what questions about pointers you have? Before I erase all of it and switch to references.
Can you make a pointer to a function?
You can make a pointer to a function, and that's how functional programming was done back in the day, but that's way beyond the scope of this class. But you can do this, yes. You can do, so basically, look, the thing is that in programming in general, and in C++ in particular, everything is stored in memory. Functions, objects, classes, variables, I don't know, everything you want is cin, cout, all of them are stored in memory. And if they're stored in memory, it means that you can theoretically have a pointer to them. But that's way, way, way beyond the scope of this action. So talking about references. So a typical reference looks like this. Int reference A equals to what? Can I write equals to 5? So what I can write here? Can I write int reference A equals to 5, for instance?
No.
If I could, would I ask you? Will I ask you whether I could? If I could, no, I will just do it. So there is some interesting thing. But before we proceed, I want everyone to understand that, look, we have 4 things. We have a reference, we have a pointer, I don't know. We have address of operator, and we have the reference. And all these 4 things are completely different. They're doing completely different role. Even though here we both use the same character, and here we both use the same character. Those are completely different things. This is a pointer, this is, and this is. So this is to get a value from a pointer, this is to get a pointer from a variable. This is, well, a pointer, right? So a thing that holds an address to a thing. Then what's this? What's this?
This alias.
So the easiest way to remember what a reference is the idea of alias. Did you play such a board game before?
Yes.
Have you heard of board game alias? What alias means? Give me a definition. Luna, your chance to tell. What's alias?
Another name for one.
Good. So in Russian we'll say pseudonym. In English, I don't think pseudonym is actually a thing. So alias is just a second way to call something. So for instance, what's alias of Bruce Wayne? Batman. What's alias of Peter Parker? Spider-Man. What's alias of variable B? So A is just another name for B. So, and that comes very convenient, because sometimes we kind of need another name. So we need to use the name as a variable in another context, but we again don't want to copy it, right? Because copying a variable it's often bad, for not all the times, but often, for two reasons. So in both situations you need to use a variable in another place in your code.
Functions.
So for instance, imagine we have, it doesn't work that way. Why it doesn't? Here you go. Right? So imagine we want to, so we have some kind of turtle. You haven't discussed vectors, that's kind of annoying that you haven't. Okay, so imagine we have some kind of integer A. And now we have super cool function that is called multiply by 2 and print. Can you guess what function multiply by 2 and print does? Wow, you're such Sherlock. I'm very proud of you. So, so we pass A to that function, and then we print it here. Super easy code, right? Now let's look at that multiply by 2 and print function. Right, so what does it return? Probably nothing. So it's a void. Then it's going to be its name. I'm just going to put dots to not rewrite it. And as an argument, it takes an int. Right? Cool. So, and then it, does a multiply equals 2. What does the same do? Can you guess? Wow, it's so great. You're learning so much, so fast. And then it prints it, right? So what's going to be output of this program?
10, then 5.
10 and then 5. Great. What will happen if I do this?
10, 10.
So let's think it through. So let's, for simplicity, call this a different letter. So it's going to be B, and here it's also going to be B, right? Do not get confused. So we pass A here, but regularly when we passed it before without a reference, we copied an A. So an A here and the B here were completely two different variables. They had the same value, but it was physically in memory two different variables. So when we changed one of them, did the old one change?
No.
No. But now look, now we are passing a reference to A. So we are effectively saying that we have this guy Bruce Wayne, and we are sending this guy Batman to this function. If Batman dies in this function, will Bruce Wayne be alive here? No. So the same idea here. If we multiply B by 2 here, A here will also be multiplied by 2 because it's the same function. Do you see the idea? So we multiply A by 2 in one place and multiply it in both because it's the same variable. So instead of passing a copy of variable A in here, we pass a reference to it. So that's two different ways to call methods. First one is call by value, and second one call by reference. When we call by value, we create a copy of the variable, and if we call by reference, we don't create a copy. So probably the last example before I let you go. so imagine we have imagine if we have let's go even this. We have a turtle, right? Turtle, let's say t, and let's say it's created on coordinate 0, 0, and it looks to what direction it looks?
On top? Oh, no.
To the right. Okay. And then we have a function that called turn right inator. Oh, turn up inator, I'm sorry. Can you guess what function turn up inator does?
Turn up.
It makes a turn to look up. A turtle, I'm sorry, to look up. Right? So, yes, it's a reference to Phineas FM. Good job. So let's write this function. It does very simple thing, right? Again, so it's a void function. It's called blah 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 blah, and it takes a turtle. For now, it takes a turtle by value, so without any references, right? What it does very simple things. It says turtle dx is equal to 0, and turtle dy is equal to, if it looks up, minus 1. Okay, and that's all. That's all it does. And so let's imagine that in our main, after we call turn up inator, we want to print dx and dy. What's going to be output of this program? 1, 0. And if why 1, 0? So the turtle that was turned up is a copy of this turtle. So the original turtle was never turned up, only its copy was. But if I do this, what's going to be output of this program? 0 minus 1. Because actually the turtle that came here, it's the original turtle. And it's, and so it's the original turtle and it's looking up now. So the idea is that if we pass objects by value, we copy them, not only objects, any variables. By value we copy them, if we pass them by reference, we don't. How do you think most often, how do we want to pass our objects?
Reference.
Why?
We don't want to copy that.
Why we don't want to copy them again?
Time save.
Time safe, right? Because again, objects theoretically can be really big. Imagine, I don't know, you pass an array like this. Imagine an array have all students in outside, the names of all students in outside. How many students in outside we have? 2,000. So it has 2,000 strings. How do you think, how much, is it a big object? Relatively. It's a very big object. And imagine every time you want to print that object, you needed to copy it, because you send it to the function print array, and it copies that entire array every time just to print it. It will be really slow. So instead of printing it, we are sending it by alias, by reference, and that takes much less time because we don't copy anything. What questions do you have about references?
Do we have double references?
We actually do. No, I'm not kidding right now. You can have stuff like this. But that is a topic for another class, because this is L value reference and this is R value by reference, and you don't even know what's L value and R value are.
Is there a difference under the hood if we pass the address to the function and expect the pointer?
So what you're saying, if we send a pointer here instead of a reference?
Yes, and the address when we call the function.
Yes. So the thing that you guys need to understand that first of all, in modern C++, people don't like pointers. In all places possible, they either use references or smart pointers. What smart pointers are, it's again a story for another day. So pointers, it's very C-like thing. And the idea, so the question is, what if we do something like turtle pointer, and then here we do, like this, right? You mean this? And here we will pass this. This code exactly, it needs a little bit tweaks to be compiled, but generally it will work. But the idea is that references will be optimized better by the compiler, so they will work slightly faster. But you notice how much extra symbols we need to add to our code to make it work. So the whole idea why references were invented in C++ is to reduce the amount of code. Another thing that is different between references and pointers, by the way, is that references can't change owners, which is, so let me explain what I mean. So if I write int a equals 5, and then int b equals 6, and then I say int pointer p equals address of 5, and then I say p equals, address of a, yes, address of b. Will it compile?
Yes.
1 second.
So yeah, so first figure out what's going on here. So we create two variables, and then we say the pointer points to the address of the first one, and then we say that no, actually now it points to the address of the second one. It will work. So pointers can change ownership, right? While if we do references instead, right? So we'll say if we say that reference is equal to A, I cannot say reference is equal to B now. It will not compile. So that's not like in comics. If Batman dies, it dies for real. There will not be second Batman. So you cannot say that Bruce Wayne is Batman and now someone else is Batman. So that's a difference, and that difference is done for your safety. You know how many things people in C++ did for your safety? So you as a programmer don't erase your operating system. You don't make your program crash without understanding why it has crashed. So one of the things that is very dangerous with the pointers, it pointers arithmetic. How much time we have, Ayana?
It's 5:42.
Okay, let me show you one last cool thing with pointers, and then I will let you go.
I mean, technically, that's a factor.
Hmm?
Didn't we?
What?
With arrays.
What?
We did pointer arithmetic with arrays.
Yeah, you did pointer arithmetic with arrays, but what I mean, look. So imagine you do. Imagine you do int pointer. So int a equals to 5, and int pointer p equals address of a, right? And then I do the following. I less than, I don't know, 1000. I do the following. Decipher what's going on.
Now A equals to 0.
B plus I or delete more information.
A equals to 0. And then
A equal to 0 is the list of your concerns.
The problem
It's the list of the problems. What's going on? Yes,
Can
Monte.
we, like,
It will compile, by the way.
okay, we'll work.
I mean, theoretically, you should do I times 4, right? Because again, it's integers.
You're resetting the
I'm setting a memory
to 0.
to 0. And the memories that I have no rights to, right? My program only guarantees that I will have 4 bytes of memory that are mine. But I was like, oh, thank you. Actually, you know what? Instead of using my 4 bytes of memory, I'll go and and set 1,000 bytes of memories to 0. Who do you think this memory belongs to?
Other products.
Other programs, other variables in your program, to your operating system. So that's what's called undefined behavior. Why it's called undefined behavior? Anything can happen. You can set, so for instance, imagine that, I don't know, you set 0 to some byte that is a part of very important memory to your hard drive, and because of that, all information on your hard drive will be lost irrevocably. It can happen. Or you can go like this to the kernel of your operating system, and the kernel of your operating system will be set to 0 and your computer will turn off, and maybe without turning on again, and so on and so on. Obviously, operating systems try to prevent this from happening, and they're really good at this. But if you're very, 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 very unlucky, this or something like P plus 40,000 can land on that exact part of your operating system that prevents it, sets it to 0, and it no longer prevents it, and you destroy your own computer. So that's why pointers are very dangerous, and that's why in modern C++ people either use smart pointers that prevent doing this, or references that cannot be reassigned freely, so weird stuff like this doesn't happen. But pointers are still very, quite simple, and the idea is that in Turtle it makes sense. Why in Turtle we use pointers and not reference? For that example that I showed you before. Right, so we switch between Turtle 1 and Turtle 2. Reference cannot be switched from 1 to 2, so we have to use pointer. Again, if that was like a modern program in modern C++ that we actually wanted to run on some server, we would use smart pointers instead. But that's a story for another day. Any questions? Cool. So I think, yeah, you can stop the recording. And now